An important part of reporting is sending out the data we want created and summarized by email, so that various people can act on it. Let's see how we can bring data into a suitable form and send it out by email. We can use the FMT command in order to format a long list of strings into human-readable lines. Apart from emailing, I often use the FMT tool when I want to insert machine-generated content into a source code file.
As an example, consider this long colon-separated list of ciphers supported by the OpenSSL command. Let's see how we can convert it into a more human-readable format. First, I obtain the list by running the OpenSSL command with the ciphers argument. Then, I pipe the output cipher list to the sed command to substitute the colon separator between the cipher names with a space. The reason I do this is because the next command, FMT, expects a list of space-separated strings. Finally, I pipe the output to the FMT command to format it in filled lines. FMT has a default maximum line width of 75 columns, which we can modify. As you can see, on each line there are as many ciphers as they can fit in 75 columns without hyphenating them.
I have many scripts that run overnight and send out emails reporting some results. At some point, a single script sent every day emails to over 100 mid-level managers copying their director. Let's start with a simple example of how we can send a plain text email.
For this task, I use the sendmail command. We specify as its argument a list of recipient email addresses. Here, I only include one recipient, john.smith@example.com. Then, I provide the message body from the standard input. Specifically, I write the message in a here document ending with the EOF sequence. The first thing we need to specify is the header. This includes elements such as the sender, the recipients, the subject, the date, and so on. Keep in mind that the order doesn't matter. In this case, I specify that the message comes from Alice Jones along with her email address. I also include the recipient and the subject. Note that the header elements are strictly defined according to the email standards. We have to follow them, otherwise the message may be rejected. For instance, the header lines may not be overly long and may not contain non-ASCII characters. In case a header element exceeds a number of columns, it has to be broken into multiple lines, with each following line indented by whitespace. In addition, note that the header is not interpreted by sendmail to find out where the message must be sent. Consequently, the address list of the sendmail's argument must match the one of the to element. In case they don't, a spam detection program may think that something is amiss. On the other hand, this can also be creatively exploited. For example, leaving out an address from the to element, which is included in the sendmail's argument list, amounts to a blind carbon copy, the BCC email field. Finally, separated by the message header with an empty line comes the body. This is the actual text that the recipient receives. Here, I'm learning how to send email from the command line.
Let's now see how we can tailor an email's contents.
For this purpose, I create a Unix shell script which I name sendconnections.sh. Similarly with the previous example, I run sendmail, but now the sender is actually me. I also include the date element, which is the output of the command date-r. The -R option formats the date according to the email standards. I specify a subject, current network connections. Then, the message body says, these are the currently active network connections, followed by the output of another command, the netstat. This lists the network connections. Now, executing this script, I send the included list to John Smith.
In order to send out attachments as email, we must first see how we can convert binary files, which are what attachments typically are, into textual form. This is required because older email systems often choke on binary data.
Let's create some random binary data to demonstrate this concept. I run the dd command specifying as input file dev_random, which produces random bytes. As output file, I specify data, and this is where the produced bytes are stored. Also, I specify to read 32 bytes with a block size of 1. Running more on data, we get various characters in angle brackets, as you can see. These are non-printable characters, indicating that the particular file contains binary data. To convert the binary data into printable characters, I run the base64 command on the data file, redirecting the output to a new file named data.base64. Now, concatenating this new file, we see that it only contains printable characters. Furthermore, the reverse operation can be performed by running base64-d for decode, specifying data.base64 as the input file and data.decode as the output. Comparing the initial data file with the decoded one, byte by byte, through the cmp command, we verify that they are indeed the same. Thus, we converted a file from binary format to text and then back to binary, preserving its contents.
Having converted our attachments into text form, our next step is to combine them together into an email message using the so-called multipurpose Internet Mail Extensions, MIME format.
As a first example, let's send an email message containing a fixed file as an attachment. Again, I use the sendMail command, extending now the header with a few more elements. The first is MIME version, which specifies that the message is formatted according to the MIME standards. Another is content type, which specifies that the content comes in multiple parts and in a mixed format. Moreover, there is now the boundary element we've seen again in the past. This includes the character sequence that separates the multiple parts. Then come the boundary-separated parts. The first part contains the text message that the recipient reads. In this case, it says, "The attachment contains your Hadoop results." Also, each part has its own header. Here, we see that the message's content type is plain text. The second part is the actual attachment. Notice that its content type, octet stream, denotes a binary file encoded using the base64 extension. Now comes the attachment, encoded as a sequence of base64 characters. Now let's see how we can dynamically generate this attachment. In the new script, I repeat the first part of the email message. In this case, I don't escape the here document ending with a backslash. As you may remember from the early units, this allows us to run commands within the document. Here, I replace the previous date element with the output of the command date-r. In addition, instead of specifying the attachment as a character sequence, I now include it as the output of the command base64 binary data file.dat. This converts the binary file .dat into base64 format. When I type EOF, the message is sent together with the generated attachment.
This concludes our unit on reporting by email. Stay with us.